Assalamu alaikum. We're back once again with our fifth type of organic reactions. This one you know quite well, combustion reactions. I'm going to start off by saying that every organic compound, doesn't matter what functional group it belongs to or whether it's an alkene or alkyne, unsaturated, a benzene, every organic compound can undergo combustion. That's sort of their commonality, okay, the common thing between them. So every organic compound can undergo combustion. Okay. The only difference is the speed at which they combust at. Okay, that's one. So the difference. Whoops. We'll say this here. The only difference and the amount of product. So not all of them are equally efficient. Okay, which is why we choose, for example, to fill our cars with gasoline as opposed to pure ethanol. Okay, because gasoline is a lot more efficient at supplying energy than ethanol would be. Ethanol still does, but it burns very quickly. So the general format is this, right? You have an organic compound. So organic compound, whoops, and then plus oxygen. And that always gives you an X amount of carbon dioxide plus an X amount of H2O. Now, is it H2O liquid or gas? It's liquid, right? And this goes back to thermochem. It's liquid if it's a closed system. And then the rest of the time it's going to be gas. Okay? So organic compound plus oxygen gives you an X amount of moles of carbon dioxide and X amount of moles of water. And if it's a closed system, it's liquid. And if it's not a closed system, then it's going to be gas. Now, this is what we would call a complete combustion. Sometimes you can have what we call incomplete combustions, and that's when there's not enough oxygen to fully react. And as a result, your reaction could result in all or one or two of four possible products as opposed to solely two products in a complete combustion. So, for example, an organic... So the reactants would look the same. You'd have an organic compound plus oxygen and then that could result in carbon solid, could result in carbon monoxide, and that's usually the most dangerous one that we look out for. So when you burn your toast in the morning, you're making this. And so when you burn your toast, it's actually an incomplete combustion. So you could have carbon solid, carbon monoxide. You could have carbon dioxide as well, and water. The difference is that it could be a gas as well. It could be one or all of these compounds present, and it's really hard to tell when it's what. Okay, so we would still do the same thing that we normally do with combustion reactions in the sense that we would balance them. And there's really no way of telling, just from looking at the equation anyway, which or how many of these products are present in a incomplete combustion. But I would expect you to know what the products of incomplete combustion are.